Okay, hello everyone, Jogang. Let's continue with search fail. Actually, the idea here is somewhat similar to file management in UE5, especially a park file, which stacks layer by layer. At the same time, this search sometimes involves depth first and breadth first sortables, but this course won't cover all this because it's a bit far off. Personally, I feel that if you put all your energy into LeshRD right now, into algorithms, it's actually a bit of putting the cart before the horse. Because what you need to learn is Unreal Engine. You don't need to learn these. You don't need to focus your energy on these algorithms right now. It will distract you. Okay, so let's start with search fail. The search fail. Actually, from the beginning, it's the same as this. So we also need to do a simple culling like this. So how do we do this part of the work? First, we definitely need to set exit conditions. That is to exclude some files from the search file. Then match. Because why is there a search file? Is because we need to filter, because these things might be 1xe, might be h, might be, and then might also be some miscellaneous stuff, some XML or CS generated files. We only want to count our code. CP, so yeah, we need to take all files. This places all files. We filter them and then we will count. First, get a checkpoint, that is, the files we filtered. If it equals 0, then we need to exit. Then it proves we need to enter the code counting stage. So let's change the stage first, and at the same time, let's give a prompt. We are about to start code counting. Right, then we record this file. The time of this search filtering stage. Then we set this repair. And this is our recursive exit condition. It will execute every frame according to our state, because we have already determined it equals 0. Right, it is definitely not equal to 0. We take out the first file, then we still use this kind of comparison again. This writing style is quite fun. Then remove it. Then we need to check here whether this path is okay. That is, this file. It might be deleted exactly during your loop. You cannot rely on the previous information because this file might have existed 10 seconds ago, but 10 seconds later, it no longer exists. Right, so in this part, we still need to check it. So how do we do this check? This is relatively simple. The way we do this check, we actually check. We add our filter condition here. We consider this filter check passed. Only then will we process it. So what is this filter condition? First, through pass, we get its suffix. And at the same time, we get its fail pass, right? We first get the suffix and the path of this file. Then let's determine whether it is under this betterwise, or whether it is under build, or under intermediate. Actually, here we explained this in chapter 2 or chapter 3. Some are intermediate files that are not needed. If it only has, if there is even one thing that exists, it indicates there is a problem. Right, then we now determine, that is, if it is Y or CPP. If its extension is then we consider it okay. Okay, this is a filter. We correspond to the functions we haven't completed because we hard-coded it here. Let's add a note for it like this. Okay, we hard-coded it like this. Okay, then let's go back. So as long as we are here, after the verification here passes, we need to add it to our array. Then we need to add it to the actual code we are going to compute. It's such an array of constants. Then we prepare our log. That is, we have currently added the file to be processed so that you can see it. And if it doesn't pass, we also add it, because at least we tell you the reason. That is the reason it is discarded. That is, we give up processing this file because it does not meet our filtering criteria. So after doing this, our entire filtering process is done. Then let's open it up and take a look. Okay, let's search here. We'll search here again. You'll see that everything here is discarded. And then, right, there's no problem. That is, all these files, you can see from A1 to C and then to B, they are all there. All these files up to G are present, and we're quite satisfied with this order. It follows the order we see here. The order shown in the description. Right. Then next, we need to look at the calculation code. On our side, we will continue to explain to you. First, we still set our exit condition. Obviously, when all of this calculation code is finished, that is our array, because we are calling, we will manage the assets for view. That is calling this technique and then increase our number. Okay, if we have called, then we record the time. We enter the failed settlement stage. Okay, then at this point, we are still using this naive approach. We bring in the first file called technology. Then we must check whether this file exists. If it does not exist, then, of course, we won't perform this operation. Normally, we should also provide a log telling you that this file is missing for some unknown reason. But we didn't record. Not really necessary, right? Then here we prepared a TLV string. Then we take this file and load it entirely as one line in the form of a single string. After loading it, we reference this count. The number of away lines is how many lines. We add it to our inter. Right. After adding it to inter, we record this situation. So which file is it? How many lines does it actually have? We print this character. Okay, then at this point, we also need to print the current. How many lines of code we have accumulated so far, then our content code. Then we run it to see. Then here we still use this. You will notice that here we didn't seem to jump down successfully. Let's check the reason. Enter this place. Let's see if we entered successfully. Let's enter again. You can see this place. It came directly over. The reason is also very simple, because we didn't click on H and TPP. So what do? Actually, if we do it this way, let's just write one. Click on XG and H. Then we open it with VS. Let's give it a 1, 2, 3, 4, 5. Let's give it 5 lines. Okay, we need to enter here. At this point, we execute it. Then we enter again, we search again. You will find that here, it indeed calculates this file has 5 lines. Then we accumulate this to 5 lines. This proves there is no problem. Okay, then we move on to the finish code stage. Finish code is our final stage. We just need to take the previous information. Just do a summary processing. So first we give a date. That is, we need to do this. It's done because we have completed all the processes. Then we record our current completion time. This is our Felix's time. Right. And then the time here, it says from here. It says from, but it doesn't matter. It doesn't matter. It only says from here. I just didn't modify the code. Then subtract the difference between the times before and after. This subtraction is actually because we have the time here, right? We just need to perform a subtraction. Right. This is the total execution time. Phase 1 time. PH 2 time. Phase 3 time. Phase 1, browse the directory. Phase 2, filter files. Phase 3, process files. Right, so this is the total time. Actually, there should be an extra entry here. Just use this one. Okay, after that, we just add these logs in. There's nothing much to say here. It's just adding this log to a box. Then after that, we take the total number of lines of this log and print it out. We also add it to the box. Then at this point, we perform a simple release of our resources. We set this counter to 0. We also set this state to idle. That way we can accept the work of the next traversal loop. And basically, at this point, we are all done. Okay, at this point, finally, I will demonstrate to everyone whether our code is running as we expected at this moment. We can switch to another project. Let's find a project, and we can directly use this demo. This project is, let me see if we wrote a plugin. We wrote a plugin. Let's browse this plugin. You can see this plugin actually has over 3,000. Did it also include some header files? Let's just ignore him. This Weeblebats pointer of ours really has a lot of content written. You can see. Then look at how much each file has executed accordingly. Actually, we can make this area a bit larger. You can see. Look, this line of code is 67. This subsector is 67. Then look at each class. Actually, this class is quite heavy, so obviously here, it also includes the code from the third-party library. Actually, you can set up a filter here. Right, we can filter out a setter party. We didn't set up this filter. So overall, it has 800 lines of code. Okay, let's come back. We'll stop here. The content of this chapter. We still have a few minutes. Let me tell you. Can this thing be further improved and optimized? Of course, it's absolutely no problem. Yes, it can certainly be further improved and optimized. Actually, there are some details, but we won't go deeper into them because this part of the content is intermediate to advanced. How to optimize it? You can actually display some images here as well, or maybe some drop-down menus, or add a few more enumerations. That's completely fine. So obviously this task, you are still executing it frame by frame on the main thread. Then you can actually open a few more threads or something, and then divide this task further. Then have several threads do this kind of operation similar to parallel, right? Everyone should understand what I mean. It's similar to task graph, like using parallel to divide it up, then use multi-threading to optimize it further. Its effect will definitely be better. Okay, but we can no longer add this thing inside here, because doing it this way goes too deep. Then let's run it one last time. Let's see how many lines of code our program has written. Let's find our application. Find fx the user, then latest. Then let's find this engine. Then find source. Find program. Then let's find the directory below. We mainly look at this directory. Okay, actually, this small program of ours is probably just over 1,000 lines of code. It's fairly normal. It's fairly stable. Okay, that's all for this lesson. Then in the next section, I'll show you. In the next section, I'll show you how to package it. Thank you, everyone.